This video is on algebraic expressions. T minus 37 is an algebraic expression. We know that this is an algebraic expression because it has three key parts. It has a variable t, it has an operation, subtraction, and it's got a constant, 37. So these are the parts of the algebraic expression. Some might confuse this for an equation, but the key difference here is an equation has an equal sign. It would be setting values equal to each other. This does not. This is just a variable t, an operation, subtraction, and a constant, 37. Now we are going to evaluate the expression t minus 37 for t equals 40. When we say evaluate, what we mean is instead of having the variable t, we are going to take what t is equal to, the value of 40, and replace t with that value and then simplify. And it will look like this. I start by rewriting my expression, t minus 37. I continue by, instead of continuing to write t, I write what t is equal to. In this case, t is equal to 40. So you'll notice I put 40 in parentheses where t used to be. Whenever I'm evaluating an expression, I always like to take the value and put it in parentheses when I replace the variable so that I remember what used to be there is t. But now 40 is going inside. It's replacing t because that's what t is equal to. So I put it inside parentheses to make that clear. It also will clarify things when we're dealing with exponents or negative numbers. So it's good to get in the habit. When you evaluate an expression, when you replace a variable, always put the number into parentheses. Now, I simplify by doing my subtraction, 40 minus 37, and I find that the result is 3. So when I evaluate the algebraic expression t minus 37 for t equals 40, the result is 3. It's important to note that we're not always going to evaluate for the same value. We could go back and do this whole process again for, say, t equals 27, and we'd end up with the result of negative 10. So you can evaluate for lots of different values, but you're going to be asked to evaluate for a given value, in this case for t equals 40. Here we have another algebraic expression. We know it's an algebraic expression again because it's got two variables this time, s and t, two operations, addition and division, a constant, 2, and no equal sign. So we know that this is in fact an algebraic expression. This time, our directions are to evaluate for t equals 4 and for s equals 6. So we're going to go about this the exact same way we did the last problem. We're going to start off by rewriting our algebraic expression. There it is. Next, we're going to take each variable in our algebraic expression and replace that variable with what it's equal to. Notice again that I've used parentheses around the places where I replaced letters with numbers, variables with numbers. So the s is now parentheses 6 and the t is now parentheses 4 because t is equal to 4 and s is equal to 6, just to clarify. Now I'm going to remove parentheses I don't need and start to simplify this a little bit. Notice I've removed the parentheses around 6 and around 4 because after they sort of differentiate them as being replaced for variables, they have no function mathematically, so we can just take them away. The outermost parentheses do have a function. They're telling us that we must do that addition before we do the division, which is important because otherwise, with PEMDAS, we would want to do the division first. So we go ahead and we do our addition. 6 plus 4 is indeed 10, so we have 10 inside the parentheses now, and we're going to do 10 divided by 2 next. As you can see, 10 divided by 2 is obviously 5. So when we evaluate the function s plus t divided by 2 for t equals 4 and s equals 6, the result is 5. Remember, we could evaluate this function for other values. T could equal something else, s could equal something else, and we would probably get a different result. But in this case, we were asked to evaluate for t equals 4 and s equals 6, and therefore the result is 5.